Hello everybody, this is Dr. Christopher White, and in this video we're going to be looking at how do we use fresh water. So we're going to begin by thinking, well, what are the main ways in which fresh water is used? And to be clear, we are going to be discussing fresh water use in the United States because that's where I'm based. So in terms of water use in the United States, the amount of fresh water that's used every day is estimated by the United States Geologic Survey, also referred to as the USGS. And they estimate that hundreds of billions of gallons of fresh water are used each day. And just to give you some idea, it was predicted that 322 billion gallons of water were used each day back in 2015. So we are talking 10 years ago. So over time, obviously, that water use will have increased even further. But I think that gives you some idea of just how much fresh water is used every day in the United States. Now, the majority of that fresh water is going to be extracted from surface supplies. So we're talking about rivers, lakes, and reservoirs. However, groundwater is also commonly used, particularly in drier areas, so maybe like West Texas or New Mexico, Nevada, Utah, areas like that, or more heavily populated areas like California. So in the case of more heavily populated areas, they may actually have a pretty decent surface water supply, but there could be so many people in the area that they have to also use groundwater as well in order to supplement and make up the amount of, the fact that they need that extra water because there are so many people. So in terms of the water use, a very significant proportion of it, 41%, is used in thermoelectric power generation. So you're thinking, what is that? Well, thermoelectric power generation refers to the use of coal or natural gas, nuclear power plants, or geothermal plants to produce electricity using water. And so in these facilities, what's happening is you are essentially taking a heat source. It could be burning coal, it could be burning natural gas, it could be the heat produced from nuclear material, or it could be geothermal heat produced by the earth itself. Either way, what you're doing is you're taking water and you are evaporating it. You are turning it into a gas. You are producing steam. And of course, what happens is when you take water from the liquid state to the gaseous state, you are essentially causing a volume increase, and so the pressure that's produced by that production of steam can then be channeled along a pipe, and so the flow of that steam can then be used to turn a turbine, and that turbine will then be used to essentially produce electricity using a generator. Now, in terms of the water that's used to actually produce the steam, the majority of that is going to be fresh water. You don't really want to use saline water because of the very large amounts of dissolved material in it. So you have a lot of salt, for instance, in saline water, which when you produce steam, what's going to happen to that salt? Answer, it's going to precipitate onto the walls of the tank in which the steam is being produced. So over time, you'll build up more and more and more salt, and eventually you'll end up essentially blocking up your equipment. So typically when you are using water to make steam for power generation, you are going to want fresh water. Typically you will also you'll also try to get rid of some of the dissolved material from that fresh water as well to make it as pure as possible, to limit the amount of damage that is done to your equipment by that water evaporating. Now, another thing is that you obviously want to recover the water that you've turned into steam, because if you can, turn it into steam and then condense it again, and then you can reuse that water practically forever. And so how do you recover that water that you turn into steam? Well, in that case, you have to use condensation tanks. So a condensation tank is simply a vessel into which that steam is channeled, and within that vessel, there are other pipes moving throughout it, and those pipes contain cold water. And that cold water could be pumped from a river or a lake, or it could be pumped from the ocean. Either way, that water moving through those pipes helps to cool down the steam, and that allows the steam to condense back to water, which can then be collected and used for steam generation again. The heat that's taken from the steam is obviously transferred into the water that's being used for cooling, and this is the water that's being taken from rivers, lakes, or seas. And so this water obviously becomes noticeably warmer. And the thing is, though, is that the water itself, although warmer, it's not contaminated in any way. And so what you can do is you can pump the water in, use it to cool down the steam, and then once you have cooled down the steam, you can then pump that warm water back out, and that can then be pumped straight back into your river, your lake, or your sea. And because it's not contaminated, it doesn't typically do a lot of damage, although I should point out that the fact that water is noticeably warmer than it was obviously when it was removed from the body of water, well, that is a bit of a problem, and so it can cause local environmental damage because of the warm water being pumped out from the power station. So in terms of water loss due to power generation, it's actually quite low because the water that's being used to make steam is just being cycled again and again and again in the power plant, and the water that's being used for cooling, well, it's taken from, let's say a lake, and then it's just returned to the same lake. So you're not really losing any water there. So yes, a very, very significant amount of fresh water is used in power generation, but the actual amount that's lost, to be it the atmosphere or due to contamination, is actually surprisingly low. So the next major use is irrigation, and this accounts for 37% of freshwater use. So in this case, it's being used for the growth of plants and animal products. Now, the majority of this water is going to be used in the irrigation of crops. And irrigation of crops is a very water inefficient process. So essentially you have a situation where water is being sprayed onto your field of crops, and in a lot of cases, a very significant amount of that water will never actually make it to the soil. A very large amount will either just simply evaporate straight back into the air straight away, or the water will get caught on leaves and just sit there on the leaves, and then that will also over time evaporate away and go back into the atmosphere. So only a relatively small proportion of the water that's being used for irrigation will actually make it down into the soil where it can be used by plants. So the high rates of water loss can lead to water sources being overexploited for irrigation purposes. And of course, this will cause significant damage. So in some places, they have tried to reduce the amount of water that's being used for irrigation by simply supplying the water directly to the plant using irrigation pipes. And this obviously can only really be done for long-lived plants. So if you think of something like an almond tree in California, what you can do is, instead of just, spraying water everywhere and losing a whole load of it to evaporation, instead you just lay down a pipe that runs along the base of all the trees, and it has little holes in it. And obviously, as the water is passed down this pipe, some of the water will exit the holes directly into the soil at the base of the tree. So this tree has a nice steady water supply, and at the same time, you are not using or losing significant amounts of water to evaporation. So that's a more efficient way of doing it. Problem is that the vast majority of crops, so if you think of corn or wheat, well, those are bulk crops where putting in irrigation pipes, it doesn't really work. So you have to stick with the traditional way of doing it, which is just simply to spray water all over them, which is very water inefficient because a lot of that water just goes up into the atmosphere. And so you have to wait for that water to then be dropped down again in the form of precipitation. So a really good example of what happens when you overexploit a body of water for farming, for irrigation, is the Aral Sea, also referred to as the Aral Sea. And this is, or was, should I say, a body of water that is located on the border between Kazakhstan and Uzbekistan, although at the time that this started, they were both part of the USSR. And so what happened is water was taken from the rivers that fed the Aral Sea. And so this water was diverted for farming purposes, and so obviously less water was going into the lake, the Ariel Sea. And to be clear, this is an absolutely huge lake which supported very large populations along its edges. And so, this was a very, very important body of water in that area. So by reducing the amount of water that went into the lake, what happened? Well, evaporation kicks in, and obviously you're losing a lot of water to the atmosphere, but that water that's being lost is not being replaced. And so over time, the lake is going to start to get smaller and smaller and smaller. It's going to shrink. And obviously, as the water evaporates away, it causes the water that's left behind to become more and more saline, more and more salty. And so what does this do? It kills any fish that are there. And so the Ariel Sea, which was a very, very productive freshwater fishing area, essentially the fish stocks die off, so fishing collapses. That obviously means if you're in the fishing industry, you've got to go somewhere else, so you've got to leave the area. And then to make things even worse, once the water evaporates away completely, all the sediments that were on the bottom of the lake are exposed. And of course, that's mostly fine clay-like material. And of course, that then starts getting picked up by the wind, and you end up with dust bowl conditions. So if you're in, something like farming, once again, well, you've got a whole load of dusty air constantly moving around. It's bad for farming. It's bad for people who breathe it in. And so once again, that's going to cause the population to collapse in that area, and they're going to have to go somewhere else. So the Ariel Sea, as you can see down here in the bottom left, that's a satellite image of it all the way back in 1989. And this is what it looked like in 2014. And the situation has gotten worse since then. Now, the Kazakhstan government, so the Kazakhs, did actually decide they were going to do something. So in terms of where Kazakhstan is located, it's located towards the top of the lake. And you will notice that there is a narrow point right here. And what the Kazakhstan government did is they built a dam across it. So right here, there is a dam. And obviously this helps to retain water in this northern portion of the lake. And so by constructing this dam, what's happened is over time, the lake level has risen by 42 meters to a more historic level. And obviously, as the water level went up, that meant the water became less saline, and then fish species began to return to the area. And so this small area up here has been essentially, to a degree, repaired and can now be used for fishing again. So, there are some things that can be done to try and help the situation, but in terms of actually, getting the whole lake itself to reappear, that's pretty much impossible, because so much of the water that used to go into it is now used for irrigation purposes, for farming, or it's used for residential purposes. So it's just no longer accessible or can be put into the lake anymore. Okay. So what about public and domestic use? Well, this accounts for 12.6% of freshwater use, and it covers water that's used in drinking water, used for washing, used for watering plants, and used for other non-industrial business uses. And a significant amount of this water will actually be recovered through treatment plants. So when you think about, you flush your toilet, or water goes down your kitchen sink, or water goes out of your washing machine, it goes into a load of pipes. That water then gets directed back to a treatment plant, where a couple of things will happen. The water will simply be treated, and it will be released into lakes or rivers, or maybe the water will be treated and then it can be reused again for residential purposes. So the actual amount of water that's used for things like drinking and washing is actually, pretty decently recovered. You don't lose a whole lot of it. In contrast, the amount of public and domestic use of water that's used for watering plants, well, that's considerably higher, because just like irrigation, you lose a lot of that water to evaporation. So it's very, very water inefficient. It's not great at all. So in terms of industrial uses for water, that accounts for about 5% of freshwater use. And water is used in a whole range of industries. So it's used in the manufacturing of paper, fabric, steel, plastics, cement. So, a lot of different uses. And the problem is that to replace that water in those manufacturing processes, to try and save water, is very, very difficult, because whatever you try and replace the water with, it's going to be way more expensive than just using water. And so, the possibility of replacing the water that's used in, let's say, paper making with something else doesn't really work. So industrial uses, they require a constant supply of water in order to make their product of choice. Now, the problem with industrial water is that in a lot of cases, it will become contaminated during its use. Now, this is a problem because once it's contaminated, that obviously makes it more difficult to reuse that water again. So typically what will happen is companies will treat that water before they release it back into bodies like rivers or lakes, where the water can then be diluted by a larger volume of clean water. Now, this process of treating the contaminated water is the responsibility of the company. However, they are obviously overseen by the government, and the government will tell these companies what they have to do in order to clean the water sufficiently to allow it to be re-released into rivers and lakes. Now, another use for water is mining, and this accounts for about 1% of freshwater use. So the water that's used in mining can typically be used in a couple of ways. It can either be used directly in the mining process, and this primarily occurs during the mining of clay minerals, where the person doing the mining essentially uses a really high pressure hose to blast the rock that contains the clay minerals. And obviously the force of the water makes the rock break up, releasing the clay minerals, and then the clay minerals can be collected. However, the main use of water in the mining industry is as part of the processing system. So during this processing system, what you're doing essentially is you are taking your ore, your rock that contains your mineral of interest, you're going to crush it to a fine powder, and then you're going to mix that fine powder with water to produce what's referred to as a slurry. And that slurry will then be processed to recover the mineral of interest from it. That once that will produce what's called a concentrate, which can then be sent to a smelter. And then what you end up with is a whole load of water that contains the stuff from the rock you don't want. And obviously, that's a bit of a problem because that water is now contaminated. So what's going to happen to that contaminated water? Well, a couple of things can happen. Either that contaminated water can be treated by the mining company, and if it's treated, then it can be used again. So it can be cycled back through the system again and again and again, and that's good. It reduces water use, which is a positive. However, there is always going to be some water that's so contaminated that you can't reuse it. So what's going to happen to that water? Well, if that occurs, your water is going to be pumped into what's called a holding pond. And in the holding pond, it's literally just like a reservoir, and all that contaminated water is going to go into it. And so once that water enters the holding pond, what's going to happen? Well, some of it's going to be lost to the atmosphere through evaporation, but some of it is also just going to stay in the holding pond. And when it's in the holding pond, some of the fine particles within the water will begin to settle out from the water and form a layer on the bottom of the holding pond. And then once all those fine particles have left it, maybe that water can be reused to use for mineral processing. Although, to be fair, in the vast majority of cases, once that water leaves the holding pond, it's not really going anywhere apart from through evaporation. And so in that case, you have a situation where you've produced a volume of very contaminated water, which can't really be used for anything else. So it just has to be held in place until evaporation does its thing, causes that water to leave. And obviously, as the water evaporates away, all the material that you don't want is essentially left behind in the holding pond, and then later on you can then cover over that holding pond with things like clay and soil in order to essentially bury it. So around 2.5% of fresh water is used in aquaculture. And aquaculture is a term that isn't very commonly used, but essentially it covers the use of water for growing stuff in aquatic environments. So we're talking about fish farming, we're talking about shellfish farming, and we're talking about a relatively niche use, but we're also talking about the use of water to grow aquatic plants for things like aquariums. And so, in the case of fish farming, let's say some of the water is used for something like catfish farming. In the case of shellfish, it might be used to grow mussels. And like I say, in the case of aquatic plants, it would be used to grow aquarium plants. Now, in terms of the United States, a significant proportion of aquaculture actually takes place in the state of Idaho in an area called the Thousand Springs area. And this, as the name suggests, is an area where you have multiple freshwater springs from where water can be taken and then it can be used in aquaculture. Now, the nice thing about aquaculture is the water loss is relatively low because the water is taken from the springs. It's used for essentially, the growth and development of aquatic species. And then once you've used the water for that purpose, you can pretty much just put it into a lake or a river and everything is relatively okay. Some cleaning might be required. So for instance, if you are using things like antibiotics to treat your fish, you will obviously have to be careful about how much you use because you don't want to contaminate the water that you're sending further downstream. Another thing that you need to be aware of is that you need to also take care to avoid releasing invasive species further downstream, because obviously that could become a major problem later on. Now, the final use of freshwater is going to be for livestock, and this accounts for just over 0.5% of freshwater use. So in the case of water used for livestock, it's going to be used for water for consumption and by the animals, for the washing of the animals, and also for the production of feed. So we're talking about things like hay and alfalfa, plants specifically grown for use as livestock feed. Now, it should also be noted that a significant amount of livestock feed does actually come from byproducts of farming. And so a significant amount of animal feed actually comes from back up here in the irrigation bar. So the actual amount of water that's used to make hay and alfalfa is actually relatively low compared to the amount of feed that comes as a byproduct from irrigation. So in terms of the amount of water that's used by ranchers, ranches tend to be quite large, which means they tend to be located in areas which are away from large amounts of habitation. These tend to be areas where the conditions are a bit tougher, and so these could be areas that don't receive rainwater, large amounts of precipitation for extended periods of time, and so ranchers will typically construct small reservoirs and ponds which they can use to retain water, which can then be used for their livestock. Obviously, just like any situation, once the water is used, it can then be treated and it can then be returned to a river or a lake. So once again, in terms of water losses through livestock production, relatively low. So those are the 7 main ways in which fresh water is used in the United States. So now we need to think about, well, how do we use water and how do we store that surface water? So in terms of using surface water, what can we do with it? Well, obviously we can use that surface water to produce hydroelectric power, which is, extremely helpful and very environmentally friendly. We can obviously also use surface water for recreational purposes, so think of something like canoeing. And water is also extremely important when it comes to transportation. So a river is a very effective way of getting your product from the coast inland. We also sometimes will construct artificial rivers to allow this to happen. Of course, those are called canals. Now, in terms of how we actually store our surface water, well, a lot of it is stored naturally in the form of lakes and rivers, but we can also produce artificial stores in the form of reservoirs, and we can also produce artificial rivers in the form of aqueducts, which essentially are just designed to move water from one location to another. So the next question is, how do we actually measure volumes of water? So when we discuss volumes of water, we typically use one of 3 units. So we talk about gallons, we talk about litres, or we talk about acre feet. So gallons and litres are terms with which you are probably very familiar, so we're not really going to worry about them. So we're actually going to focus more on the term acre foot. So straight away, you're obviously asking yourself, well, what's an acre foot? So an acre foot is exactly as the name suggests. It's the amount of water required to cover 1 acre of land with 1 foot of water, hence the name acre foot. So in terms of an acre itself, you're probably thinking, well, how big is an acre? So an acre covers an area of just over 4,000 square meters. That's 43,500 square feet. And, just to give you some idea about the dimensions of an acre, you would have to imagine a square where each side is about 64 meters long, or 212 feet long on each side of your square. And that gives you an idea of just how big an acre is. Now, if you want a more well-known way of visualizing the size of an acre is equivalent to to essentially 91 yards on an American football field. So we can see here's our football field, and you can see we're starting from 0 over here, and the acre is essentially going to be at 91 yards over here. So all of this area right there, that's going to be your acre. So, like I said, an acre foot is defined as the amount of water required to cover an acre of land to 1 foot of water depth. And this is equivalent to about 326,000 gallons or 1.2 million litres. So you're probably thinking, well, hold on a minute, acre feet, it doesn't really seem like a particularly helpful unit. And I will freely admit it is a bit of a strange unit. However, it does have its uses. So to begin with, as you can see here, an acre foot contains 326,000 gallons or 1.2 million litres. And so what you do by using acre feet is essentially it allows you to use smaller numbers, which is always helpful when it comes to, discussing the amount of water that's being used for an area. Now, acre feet is also quite useful when you are talking about water that's being used for something like farming, because farms tend to be defined by their number of acres, and so you can use acre feet as a method to better monitor how much water is being used per acre of your farm. Okay, thank you for watching, everybody, and have a good day.